All right, so these two magnets are forming a magnetic field in between them. So if I place a magnet in between them, so it straight away comes in equilibrium condition, rotational equilibrium. It shows no rotational effect. If I somewhat displace it, it again tries to align itself along the electric field. Okay, now what if I rotate it and somehow I try to adjust it? Okay, so somehow we have achieved an equilibrium. But if I displace it slightly, and see, remember this north pole is this side. So if I slightly displace it, it never comes back. So this is what we call stable and unstable equilibrium. This is a stable equilibrium when if we slightly displace it, it returns back to original position, stable equilibrium. And this is unstable equilibrium. Somehow what we have managed it to be in equilibrium and it comes back. In the same way, if an electric dipole is placed along the direction of external electric field, so that theta equal to 0 here, so it will be called in stable equilibrium. For that, tau equal to PE sin theta, theta is 0, so torque will be 0. No rotation, that is why it is in stable equilibrium. And if we slightly displace it, it again returns back to the direction of electric field. But if dipole is placed in such a way that is its direction is opposite to the direction, we know that the direction of dipole is negative to positive, so it is the direction of dipole moment actually, and this is external electric field. So in this case theta is 180 degree. Again, torque acting here is 0. We know sin 180 is 0. And this time we call it unstable equilibrium, because if we slightly displace it from its original position, then we know this positive will go this side, negative will go this side, and it will be rotated. So stable equilibrium when both P and E are in same direction, theta is 0. And unstable equilibrium when P and E both are in opposite direction, theta 180. In both cases, torque is 0, but in stable equilibrium, if we slightly displace it, it returns back. And in unstable equilibrium, if we slightly displace it, it never comes back. So moral education here, we can learn a moral value here, that your concentration should be in stable equilibrium, so that if slight deviation arises around you, you would return back to your original position instantly. Not an unstable equilibrium, so that if slightly disturbed or slightly deviated from your task or study, then if you are unable to come back. And the same thing with the discipline also. If you are disciplined enough, so that if there is a chance to be indisciplined, but yet again you are disciplined, so that is stable equilibrium. And if we have somehow forcefully made you disciplined, and if you are getting a slight chance and you are becoming indisciplined, so this is how we can learn many things. Bye.